Alright, so guys, if we're going back to our notes here, I'm going to go ahead and put down Roman numeral 2. We're going to talk about when the limit does not exist. And guys, when we talk about limit not existing, that does not exist, we'll often abbreviate it to DNE. Okay, you're going to see that a lot. You can just write down DNE, does not exist. Okay. All right, so first example is you can plug this in your calculator. So example 3, it's going to ask you to find the limit as x approaches 3 of the absolute value of x minus 3, all divided by x minus 3. Okay, so set up your table. Use your table of values to prove or show to me that the limit is not going to exist in this instance. So that means if you're getting something right before 3, what would be one value you'd want to plug in for x? Something right before, you're going to get close to possible. 2.9, right? 2.99, 2.999. And then at 3, you can see it's going to make it undefined. What would be something right after 3 that you could use? 3.001, right? 3.01 and 3.1. So I'm going to set my table as well. Yeah, guys, if you don't know where absolute value is, you just heard it right there, but you can go to y equals here. Remember, you go to math, I think it is, right? And then over to number. So hit math and go over to number, and there's absolute. It might look a little bit different on your calculator if you have a newer version than me. So remember, it's math. If you want absolute value, go over to number, and you can choose absolute value from there. Depending on what your calculator's mode is in as well, so like when you graph it, if you want to see what it looks like, do you see how mine does not connect the two, right? If yours is connecting the two, you might want to go to mode and actually maybe change it to dot. I guess mine's doing okay, but if yours is connecting them, if you change it to dot, it will make sure that the mode doesn't allow it to be connected. What did you ask? Does it look nothing like that? I just pushed. What's that? Oh, yep, there you go. Gotta use parentheses around things. Yeah. How can it equal 3? Yes, so that's why I put a little x there. It's going to be undefined. Limit is a value that your function approaches. Undefined is when you have 0 over 0. A limit is something entirely different than undefined. Okay? Would this have what? This actually has more than just a hole in its graph. If you look at the graph, it has a jump, exactly. So, does a limit exist here? Does it approach the same value from the left and from the right? No. Okay, so exactly. So guys, as we come from the left, what do we get? -1, -1, -1. As we approach from the right, we get 1, 1, and 1. Okay, so I'm going to write that it does not exist. And what if I just asked you this? What if I just asked you the limit as x approaches 4 from the right-hand side of this function we'll call f of x? What would it be? So if I was approaching it from just the right-hand side, what would it be? Just be 1. Very good. I wanted you to, that's just kind of a side note there. But. All right, let's look at another example. So here we had kind of like a jump. All right, another one would be example 4. So I'm going to ask you to find the limit as x approaches 0 of 1 over x. So again, you're going to want values right before and right after 0. So entered into y equals. I don't think there's many parts to it, so no. Guys, what's the value right before 0? It's going to be negative point something. If it's negative 0.9, negative 0.99, aren't we approaching negative 1? Yeah, negative 0.1, negative 0.01, negative 0.001. Okay. And on the other side, you could say 0.001, 0.01, and 0.1. If it was 0.9, you'd be approaching 1, 0.99 and 0.999.
Oh, okay. 1 over x.
Yeah, you can put 0 in the middle if you want. What's going to end up happening, Matt, is whenever you have 0 there, you know that it's not going to be there. So you can include it or you don't have to. Think about the graph of 1 divided by x, right? Did you hit graph? Right? So this is what our graph looks like. There's an asymptote there. Okay? Abby, what did you get for negative 0.1?
Negative 10.
Negative 10, good. Connor, what did you get for negative 0.01? Negative 100. Don, what did you get for negative 0.001? Yep, negative 1,000. So here you have your asymptote where it's approaching negative infinity, right? Jared, what did you get for 0.001? 1,000, good. Let's see, Natasha, what did you get for 0.01? 100, good. And how about for 0.1, Kutak? 10, okay. So you can see here, we are obviously approaching different values from the left and right hand side, right? And here we're dealing with an asymptote. Okay, so let's put asymptote on the side there. All right, last example, guys. Example 5. I'm going to have you find the limit as x approaches 0 of sine of 1 over x. Okay, so go ahead and create your table of values, plug it into y equals, and show me proof of why this limit is not going to exist. So for number 4, guys, I'm going to put up here, again, does not exist. And my final answer would be does not exist. In order to write that down, though, you need to show me some proof, whether it's that table and you can also put your graph. The graph is kind of weird for this one. Might be kind of hard to see exactly. If you turn to in your packet page 3, the very bottom graph there, is actually showing you a better view of what's happening in that one. So this very one, bottom one on page 3 of your packet. Yeah, you can zoom in as well. And you're going to see here, guys, your graph is actually oscillating back and forth as it approaches 0. Okay, so it's not approaching a value. It's actually oscillating back and forth, back and forth, back and forth. Okay, so it's not approaching an exact value. So when you set up your table again, you can do the same way. You can use the same values as our last example. But you're going to end up seeing that the limit does not exist. And the reason being is as x approaches 0, right? F of x is actually oscillating between -1 and 1, I believe. Okay? So I'm just going to make a note here on the side. So the first one we were dealing with a jump. The second one we were dealing with an asymptote. Here we're actually dealing with a function that's oscillating back and forth. So I'm just going to write that it oscillates. If you zoom in, actually, can anyone answer that question?
Zoom and then.
You have to click. So you have to hit enter. You got it. And you can keep zooming in if you want. So if you get really close, you can see how it's oscillating a time back and forth there.
Zoom to.
Zoom to, yeah, there we go. And then you push enter.